Well, as you can see on the screen, I'm Adam Forsyth. I'm a software engineer and community lead at Braintree Payments. We make it easy for you to accept credit cards, PayPal, and all kinds of other payment methods online and in mobile apps. You can all see the title of the talk. It's Python not recommended, so of course, first thing you have to do is get that out of the way so we can get to the content of the talk. I mean it quite literally. It's not a joke. At work, we have Python considered to be not recommended. We have something called the Braintree Radar, and it contains information on the technologies we've used in the past and are using currently, why to use them, why not to use them, what they're appropriate for, whether you should pick Memcache or Redis, things like that, examples of best practices for using them within our code bases and similar things. And since about a year ago, Python is specifically listed as not recommended under languages and frameworks, despite it being currently in use and something that we have relied on in the past. So this talk is about why we used it originally, why it's not recommended, and what we do still use it for, and what we're going to be using it for in the future. So first, some background. The obvious question is, what do we use instead if we don't use Python? And my lead-up questions may have given you a hint. The answer is Ruby. Braintree, meaning everyone but me, loves Ruby. We use Ruby by default, but I promise it's not a Ruby talk. I don't love Ruby. I like Python better, but we've really bought into the Ruby ecosystem at Braintree. We use Rails as our web framework. We use Capistrano for remote configuration management. We use Puppet to actually manage the configurations themselves. And then we use Rake for various scripting, automation, and building tasks. That's not actually the Rake logo. It's just a picture of a Rake. If Rake has a logo, I don't even remember, but it was bad, I think. So what's it like doing Python at a Ruby shop? And what's it like being a Python advocate within a company that mostly prefers Ruby? First of all, you get a lot of jokes because Python doesn't have real lambdas or things like, oh, I like my closures. I don't want to switch to Python. It's just because normal functions can't be defined as an expression, that they have to be defined as a statement. And so you have to be a little more intentional about scoping things within each other. It's seen as inelegant to a lot of people compared to things like Ruby or Elixir or Clojure, partly just because the syntax is so structured. And it's a lot of people who don't really follow the tech world that closely think of it as a dying language because of some of the noise around the quote-unquote failure of Python 3. I think this is hype. I think that slow adoption and failure are two different things. I think most people probably agree with me. But there are people who work in technology and may be active in other communities who think that way. The languages Ruby and Python are superficially very similar, and I think that this causes some problems. People apply Ruby idiom to Python, and so a lot of our Python code can look a little weird. And then if somebody wants to come work with us and they send us a code sample in Python, people will say, oh, this doesn't match this or that standard that are very specific to Ruby and not Python. So things get judged as if they were Ruby a lot of the time. So despite using a lot of Ruby, wow, that's really blurry on that screen. We really believe in using the right tool for the job. If you've ever tried to put a screw in with a hammer, something that I have in fact done, it's really not fun. So we don't always use Ruby. So when is Ruby not the right tool for the job? The answer is we've sort of found historically two big umbrella conditions. One is when we want the JVM ecosystem for some reason. And this has happened to us time and time again. We've experimented with JRuby. Some people have a lot of success with it. I almost said that our experience with it have ended in tears, but I decided that's a little cruel. It's more like it's caused headaches. But despite that, there's still a lot of reasons to choose the JVM, even if you can't use Ruby. The first one is that as a payment processor, we deal with a lot of very old-fashioned financial companies. And so they'll provide us with an undocumented library for an undocumented API, and our choices are C++ or Java. Well, if those are the choices, we're going to tend to choose the Java library, which is the original reason that we started using JRuby on the JVM. We've also started to take advantage of Apache Kafka, and we found that that actually works best when you use the Java or the JVM client. We've used this from several languages, but on the JVM most successfully. And Kafka is a message broker for handling high-volume data feeds. We've also experimented with Apache Cassandra. Again, best success on the JVM, and that's a distributed database that many of you have probably heard of. So what do we use? I've mentioned this a little bit. We used JRuby as well as Java historically, sometimes together in Frankenstein apps that involved multiple JRuby containers and custom queuing systems and all kinds of noise. We've also more recently had success with Clojure and also Java still. I think that if I were to decide, we would do as much in Clojure as possible, but there's a lot of other opinions on the team. The second, this is the logo from a party that Braintree threw at South by Southwest last year, but it does look pretty smart, so that's why I used it here. We are basically, Braintree is one big smart proxy. We proxy between the banks and the credit card networks and the merchants like Uber or Airbnb or people like that. So we're basically just shuffling things around between other people. We're not the endpoint for very much. And so we, as a part of that, of course, everything is fractal. You look within Braintree. Braintree is made up of a whole bunch of smaller smart proxy servers. We have very high uptime requirements, and so we need to be available even when there are like temporary networking problems. We need to fail over services. We need to run database migrations, often on rows with billions of records, tables with billions of records. We frequently get 10x traffic spikes, and services behind us, like the banks or credit card networks, will go down, and we need to keep serving traffic. Now, even if requests can't truly succeed, they need to fail gracefully. So in order to do this, we basically just insert a lot of proxy servers all over the place. So we use them to make our outgoing connections appear highly available to internal services, even if they really aren't, so that the error handling can be done more gracefully. We have historically used it to pause incoming requests so that people can still connect to us, and within the 50 seconds or so we get before HTTP requests time out, we can do crazy operations on the database without anybody being able to tell, because we've got those connections held open, but we aren't actually processing them. We've done a lot of custom rate limiting. We have all kinds of SOA, service agreements with various merchants, and we have lots of different rules about how we want to prioritize certain traffic over other traffic because of what people actually care about. And so a lot of this is really not something you can do easily in a standard tool. We have often had to support non-standard SSL and the sort of persistent connection configurations, often because of legacy services we're interacting with, or even just in order to support badly behaved clients. We have complex retry logic and more. As you can see, there's a lot of bullet points on this list, so you can see why these end up being custom applications. And this is where we've historically used Python. Some people might think this was an odd choice. We're talking about handling requests. There's a lot of concurrency needed. But actually, Python, again, historically was a really good fit because of Tornado. It allowed us to get all the benefits of Python, like it was pretty easy to understand the code, and we could develop rapidly, and it was sort of a lingua franca for a lot of the people who worked at Braintree. But we still got the necessary I/O concurrency that people certainly didn't expect and we didn't know how to get from Ruby 5 years ago. So we're going to take a step back into the past. Python at Braintree in 2013. Python is in use for several different proxies. It served us well for a couple of years. We have several internal advocates at Braintree, like me, for Python. And yet, as you saw earlier, by mid-2014, we were recommending against using it. So what happened? I think there's a couple parts to it, and a lot of it is certainly down to us and how we handled Python as opposed to how we handle Ruby. But also, I think a lot of it has to do with the tools we selected. The platform did fail us. Concurrency in the framework really started to feel inelegant to people who were getting used to languages like Go that made concurrency really easy and provided it as part of the language. We found that modern versions of Tornado had a lot better APIs for doing concurrency. You didn't end up in callback hell, but it was a lot of work to move to a new API, and we found that these are services that we just want to sort of run on and do their thing, and we don't want to have to spend a lot of time maintaining. And if we're going to do a big upgrade, we might as well reconsider the language. And because we were stuck on an outdated Tornado version, and I use stuck kind of loosely, I'm sure we could have upgraded and still use the callback API, but a couple attempts to do it failed, partly because of lack of expertise and also partly just because we were using it in a relatively complex way. So the maintenance overhead was high. When you Google something about Tornado, your answer you're going to get is going to be you should upgrade to the newer version. And when you're on an old version and you can't move forward, that's really pretty frustrating. We found that logging within the Tornado processing had basically destroyed your concurrency and had a really high overhead. And there's no SNI support in Python 2 historically. Now that has been backported in 2.7.9, but the version of Tornado we're using is actually too old to take advantage of that feature. So even if you upgrade Python to 2.7.9, you still don't get SNI support. SNI is a way of serving multiple SSL certificates on the same host and port from the same server that many of our clients' hosting providers use. The applications we wrote have also failed us. It's not just the platform. The smart proxies were really too smart. The logic got really mixed in with the sort of concurrency boilerplate, partly because it was all callbacks and things do tend to sort of get all strung around if you do that, but also just because they were trying to do a lot of things. And the logic really became coupled, and so we would go and change our request pausing and it would break our rate limiting, and we'd end up rolling back the change. So things would get sort of frozen in time because any change would break something else. The rate limiting code was just not fast enough. The sort of straightforward, naive implementation just wasn't working. And that became a big problem, and attempts to rewrite it again broke other features. The proxies were also not smart enough. There was duplicated logic between sort of our main applications and these proxy servers, and the logic couldn't just live in one or the other. So this would be a problem anytime if you don't want to maintain two copies of the same code, but especially when you have to maintain one in Ruby and one in Python, it can really be a problem. And the applications just weren't built for horizontal scalability. We didn't really envision these still running at a time when we would have grown hundreds of times. And we ended up still using them after we had grown hundreds of times. So the architecture sort of assumed that a small number of instances of these proxies would be enough forever. And so not a lot of thought was put into how to truly make them horizontally scalable. Wow, if you could see my presenter notes right now, there's a lot of typos. So what are the solutions? What did we sort of switch to from Python switch? That's the word that's supposed to say. So first of all, our sort of incoming proxy that takes requests from our clients and can pause them or rate limit them or reject them if necessary. That does sort of approximate rate limiting and load balancing. We replaced with Nginx plus HA proxy to handle queuing and rate limiting and stuff like that. And we were able to get almost the same behavior we had in Python, just with Nginx and HA proxy configs. This was not possible 4 years ago, so Python still did a good job in the meantime. And then we don't need to pause connections at the proxy level anymore because we now use connection pooling system called PG Bouncer that allows us to pause connections between the application and the database rather than before they reach the application. Our outgoing proxy that we use to connect to banks and credit card processing networks and stuff like that, we rewrote in Node.js to take advantage of the sort of built-in concurrency of that platform that everybody raves about. This was actually a lie. We tried to do that. It was a massive failure. We ripped it back out again and went back to the Python one in the meantime and have eventually replaced it at 90% at this point in time. There's still a little Python being used with Nginx plus HA proxy. And HA proxy 1.6 can handle all the custom SSL and other configuration that we need, which has been really nice. So the other outgoing proxy that we use to send webhooks, we've rewritten in Clojure and using Apache Kafka, which gives us some great benefits over a message broker and queuing system like RabbitMQ, and also allowed us to sort of centralize all the logic in one application instead of splitting it between Python and Ruby. And it also gave us basically free horizontal scaling and SNI support and all these great things. Except, of course, that's also a lie. We started that project. We got a great RFC. We had all these great ideas. We made Trello cards. We were really excited to get started. And then we canceled the project completely to do other things. So the result, of course, is a monkey patch tornado. We're still using the super old version, but now it supports SNI with some monkey patches I wrote. Both the sort of issue of logic duplication and the lack of horizontal scalability are unsolved. Recently, since I gave this talk last a few weeks ago, we are actually attempting to solve the horizontal scalability problem. So that is being worked on. It's being worked on in Python. So if you'd asked me even 3 weeks ago how long I thought our final Python proxy, our webhook worker, would survive, I would have told you 3 months, and now I was clearly very wrong. It's going to be around for a while. So I don't know everything. So I think that all the missteps here and all the times that we thought something was impossible and then we decided it wasn't show that there aren't any easy answers, but that there often is something that will in the long term work better than Python for us. So let's get back to sort of late 2014. So we started talking about mid-2014. We jumped back to 2013. Now we're back up to late 2014 again. All the smart proxies were on the way out, or at the very least in very bad shape in the case of the webhook worker, which isn't quite on the way out. It's not recommended for new projects, which is very official. It's in the documentation on our GitHub Enterprise instance. And Python also has fewer internal advocates at Braintree than it used to have. And it's not that people have left to go take jobs where they actually write Python, which wouldn't surprise anybody, I think, but isn't what happened. People are just really excited about other technologies that have matured in the time being, like Clojure and Go, and newer things like Elixir that I think people who do Ruby are very attracted to. Not me, just to be clear. I still like Python. So this makes it sound like Python was in really bad shape at Braintree. The only places we're still using it are places that we just have to. We haven't been able to replace. But actually, things are looking up. This is the most random clip art I've ever found. So we're now using Python in some areas where it shows its strengths. So instead of everywhere we use Python being places that maybe it struggles a little bit, we're using it in places that people can really appreciate what it's good at. Data analytics is a very obvious one. A lot of people are using Python for this now. Pretty unsurprising, I think. We've been replacing Excel for a lot of things. One-off reports, these would be people who have no outside of Excel programming experience are now learning Python as their first language. Maybe these people knew a little SQL. It's very cool. It's replacing SQL for some of our recurring reports. These are people who have some analytics experience, but it was almost all SQL or maybe a little bit of MATLAB or something like that, or Stata before. And we're finding that using Python is helping us maintain these reports much better and helping more people contribute to them because they become more structured than you get when you have one giant SQL file. They're replacing R for a lot of modeling and analysis, and this is purely our data scientists. We would let them use whatever they wanted, and they're saying we don't want to use R anymore, we want to use Python. And so that's happening really organically. So I think this really shows that people at sort of all levels of experience with programming sophistication are really making the same decision when it comes to data analytics to use Python, and that's very cool. We're also using it for infrastructure management, and it's important that you remember here that we've really bought in to using Puppet here. We've got custom Puppet modules and a big repository with 3 persistent branches that manages everything across both sort of test environments, production environments on our own hardware, as well as stuff on AWS and other places historically like Linode, although not anymore. So we've really bought into Puppet. So Python starting to get used here is I think, an interesting decision. But the thing is, in the majority of cases, we're not actually using it to replace Puppet. We're using it to replace spreadsheets again. So we used to keep track of MAC addresses, physical ports, and server locations, IP addresses, all just in Google Docs spreadsheets. And it's been really nice to get that in a more structured way in Python. We're also using it for cloud instance management. Because we run our own hardware, we didn't have any sophisticated tooling around AWS. That has been becoming unscalable. And so recently we've spent a good amount of time building Python tooling around Bodo, which we found is the easiest way to do it, better than doing it from Ruby. And then most recently, and I think especially telling, is we got some new switches that are not easy to configure from Puppet. And we were in the position of writing a very complicated custom Puppet module and custom Puppet provider. And instead, one of our engineers took a week and decided to spike out rewriting all the functionality we needed from Puppet in Python so that we could use the tools that came with the switches. And that actually ended up better than going the other way and writing it into our Puppet repository. So either way, it was going to be a little bit of a maintenance burden. But when you can't avoid that, Python still often comes out on top. And so I think that sort of being the jack of all trades language here still really can come in handy in places where the right tool for the job maybe doesn't exist. The community in Chicago for Python and around the country, obviously, is also very strong. We host a lot of Python meetups, including a monthly project night, and then we will host the main Chicago Python meetup a couple times a year. We've hired a lot of people who use Python, many of whom have been learning it in college nowadays, but also people who came because they learned about us from the meetups. And even though these people then have to turn around and write some other language at work most of the time, there's still a community, an active community of us. A lot of us give Python talks, not just me, both of our senior data scientists and one of our other engineers as well, which is a great way to get the word out about Braintree and also sort of keep connected to that community. And of course, we're going to always use Python and support it to a certain extent because some of our largest merchants use our Python client library to talk to us. And that includes Python 3. We actually have a significant amount of Python 3 traffic, and our Python library does support 2 and 3 in a single code base. So now we're back up to this year, back up to 2015. Python 2 is showing its age a little bit. This is partly as a result of some of the new currency features, or only Python 3, but also things like libraries that haven't been updated since 2.7.9 came out, still not supporting SNI, even though the underlying libraries do. Data science is incredibly important as a technical use case for Python, and I think it's going to keep Python's foot in the door of a lot of places that otherwise it could disappear entirely. Community is really important as a non-technical motivator. The Ruby community in Chicago is big, but there's certain entrenched players who really kind of have their arms wrapped firmly around it. And so the Python community has been a great way for us to stay involved with technology. And as the standard tools improve, though, I think Python is losing a use case. There's a lot of places that previously it's sort of like we'd have some problem and we could solve it with Python because we didn't know what else to do. But does that really mean that Python was the right tool for the job, or does that just mean there wasn't a right tool for the job? And instead of writing it, we used Python to sort of duct tape things together in the meantime. And I think there's a little bit of truth to that. For simple things, I think the duct tape is the right tool for the job, but in complex situations, you might be doing yourself a disservice to use duct tape, i.e. Python, all the time. So thank you very much. That's all I have. I'm happy to take questions.